Okay, so for this week's module, we're going to look at volcanoes. So we're kind of looking at the second part of the igneous rocks that we started last week. So although last week was the overview of igneous rocks, it talked about textures and compositions and how we kind of identify those types of rocks. This week, we're going to focus more on the volcanic rocks, and that'll be true in the lab also. So we're going to look at the material that makes it to the surface. So here we're looking at rocks that cool and crystallize quickly. So in general, we have a fine-grained or finely crystalline rocks here. So when we look at them, we can't really see the crystals. And so for the lecture part, I'm going to have you look at this PowerPoint, just like we've been doing. There's a PowerPoint with a little voiceover. But in addition, there's some information here in the textbook. It's the online textbook that I've been referencing in the additional resources section. So you can certainly, I want you to look through that in addition to those. And then, of course, when we're talking about volcanoes this week, we're talking about, why they erupt. But one of the big things that I want you to take away from this week is that composition of the molten material matters. And so the idea of introducing these terms mafic, felsic, intermediate is that the silica content is really affecting how violent these volcanoes can be. And so mafic stuff, remember, is the darker black material like Hawaii. They're not as destructive when they erupt because they're more fluid. So this idea of silica content and viscosity being related is something that I want you to kind of keep in the back of your mind when we're looking at these different types of volcanoes, because the way the volcanoes look and the way the volcanoes behave is really dictated by the composition of the molten material. So that is kind of one of the take-home messages here. So we're going to look at like properties of different volcanoes. They look different, right? We have like what are called shield volcanoes. Those are like Hawaii. We have stratovolcanoes. Those are like the Cascade Range, right? We have caldera type volcanoes, like that's Yellowstone. So they look different, they act different. So it's all tied to this composition and kind of this gas or water content in the molten material. So that's kind of why it erupts, and then how it erupts, and then some of the hazards that might go along with that. So on that vein, I'm going to give you a few extra videos that hopefully will help, but we're going to look at some different types of hazards you can see here in these short little video clips. Something called a pyroclastic flow is a hazard associated with some of the volcanoes, or lahars, which are kind of mud flows and things like that. And then a little footage of the Mount St. Helens eruption. So as always, I try to throw in additional videos because visually, a lot of times it's easy to see and go, oh yeah, okay, that makes sense. So that's kind of what we're doing for that. For the article this week, there is a way to measure the violence, I guess, of a volcano. And so we call it the VEI, or the Volcanic Explosivity Index. And so there's an article that kind of walks you through that. It's really just about how much material that volcano can put into the air, the atmosphere. So that's what the article quiz will be about. And then this video, remember, we've kind of taken the time limits off the video quizzes, so there is no time limits here. But this Krakatoa one is really good. It's well done, and it talks about the eruption of Krakatoa, which was a fairly large eruption that occurred, and some of the hazards that were associated with that were pretty dramatic. So I think you'll enjoy that one for this week's video. Of course, you do have the quiz, but remember, it's not timed, so you can just kind of answer the questions as you go. And then for the homework, I want to drill down to a few more questions. So when you click that, remember, you'll get this kind of, yes, you want to take the quiz, but remember, all the homeworks are untimed. And so just some more questions about, relationships of magmas and eruptions and things like that. So this is information that you're already getting from the lecture or the book or something like that. And so you can just kind of fill that out, and then you'll be done. And so that'll be what we're going to do for the main lecture portion this week. So volcanoes, volcanoes, volcanoes. A little bit about the VEI, about Krakatoa, and some additional information. And then, of course, for the lab this week, just like last week, we looked at more plutonic rocks, right? Those were the rocks that cooled and crystallized on the inside of the Earth. Here we're looking at the volcanic rocks. So these are the ones that make it to the surface. They form these kind of lovely volcanoes that we're usually, I think, used to envisioning when we hear the term volcano. We kind of think of something like this. These are the rocks that we'll be looking at in lab this week. And so, the lab is set up like it's always been. The format's the same. You can retake it and all that kind of good stuff, right? Okay, so that's what we're doing this week. And I don't think there's anything else at the moment. So if you need any help or you're having any confusion about the content, please don't hesitate to contact me.